this is a session. If somebody is wondering how Ben changed it, it's not Ben, it's Katarzyna. She's working with me. And this is about using Kind for testing, let's say, scalability problem, right? But when we talk about scalability, usually people use the terms of performance and scalability differently, but in reality, we can define performance as how the efficiency of the system, right? We can measure performance in low latency or high throughput. We have these metrics. And we can think on scalability, on the capacity of the system to grow, keeping the performance of improving the performance. So you can see that there is a relation. And if you attend SIG scalability meetings or deep dives, they always talk about this scalability envelope. That's the image that you see in the right? It's not that you have scalability is a thing, right? There are a multidimensional problem, and depending on which side of the problem, there are different factors. So you cannot say what are the limits of Kubernetes? Well, it depends on the number of namespaces and the number of per seconds and the number of services. And depending on how the amount of one things grow, it can impact or cannot impact the others. So if it's difficult to define scalability, debugging it or troubleshooting it is much more difficult. Why? There are many interacting components, right? When you have 10,000 nodes, 50,000 nodes, all these kind of things, you don't even know where to look, right? The needle in the haystack is the good metaphor for this. And the other thing is that things that you think that works one way, when they start to scale, start to fail. Because you don't even know how the CPU is impacting that, right? Or whatever. I didn't know that I was using this library that was creating an array and was storing all these things in memory. So that happened to us. So that is why it's important when you deal with scalability problems to have some structure. There are some methodologies. I'm not a big fan of methodologies. I think that Brendan Gregg is one of the authorities. I recommend his books and everything. But I never recommend to follow a methodology strictly. It's more about common sense and about understanding these best practices and how they apply. But what I really like is the anti-methodologies that he's playing. So that are, as soon as you see them, you are going to start to identify it. So you have this scale problem and say, oh, something is saying connection timeout. This is a network problem. You don't even look what is the problem coming or whatever, or the street light as, oh, this I know to use these tools. I just apply these tools, and I will figure out what is the problem based on these tools. Or the dragman approach, that is, I just start to change things randomly, and suddenly or eventually something will get fixed, and I don't know why. That's a similar thing to the random change, that then what I want to do is to improve performance, so I want to start to tune different things and to modify the things and see how the results change. Then you also have the passive benchmarking, that is just I run all the benchmarking tools that I know and show the results, and somebody will figure out something from the results. Or the traffic light, that is if everything is green, everything is working. So with that, let's move to Kubernetes. Why? One of the nicest things of Kubernetes architecture is that they have API and interfaces. What does it mean? That everything, I'm oversimplifying. The people that is too deep into Kubernetes is going to can nitpick here, but I want to ask to get in the high level is if we have APIs and interfaces, that means that everything is represented as an API, and I can interact with the system through a common interface. What is this important? Because then I can mock these interfaces, and I can create just the representations, so I don't need to have a large cluster with 10,000 nodes. I can just create these 10,000 node objects, right? And if I depend on endpoints or pods, I can create these pods, because I can put all of this in a bottle. That is what Kind gives us. I can create this cluster with the minimum necessary, and I can start to create all to consume these interfaces and APIs to emulate this complex environment, this scalability problem that I need to solve, but I cannot have a lab to run 10,000 nodes or 100,000 pods. But it's not that you just need kind and the APIs and the interfaces. You need to know what you want to test, right? You need to start to break down the problem into pieces, right? You need to identify, okay, I have this super complex problem, what things are interacting with what, and where do I think that is the problem, and what are the interfaces and the APIs that surround this problem that I can emulate. And for that, you need to have a deep understanding of Kubernetes and all these problems. So this is the theory, but we have two use cases that demonstrate that. I can guarantee that I use Kind for solving like 90% of the bugs of Kubernetes. So it's not that something that an experiment. I really do use Kind for troubleshooting of the things. And now Katarzyna is going to show these use cases.
Yeah, thank you. Thank you. So the first use case, we've been debugging the DNS issue. So while working on this AI/ML scale clusters, we noticed that there's some problem with DNS resolution. So in our test, AI/ML has been using headless services for service discovery. And headless services in DNS, they aggregate all of the endpoints that actually they are back this headless service, and a record is returning all of these IPs. And it turns out that in Golang library there is the bug that when the response size is too big, the truncated bit is sent, and in Golang it is mishandled. So when we noticed that we have some resolution issue, we just tried to split this issue and tested only the DNS in isolation. We use this information that we actually don't need to create all of the cluster with huge number of nodes or generate a lot of pods. We just needed to create headless service and emulate the IPs, or we can say that fake the IPs in endpoint slice objects. And this is what we did using the Kind cluster. I prepared some live demo how we can run different commands to see what's going on in cluster, which commands we should, let's say, run to test DNS resolution or the traffic. So let's create the cluster using Kind. Creating cluster is really easy in Kind because we can use very small and weightful configs to modify, to configure it. And using kubectl, we can access our cluster from our machine. We can say I created a cluster with 3 workers and 1 control plane. And for this demo, I already prepared some service, headless service, and generate endpoint slice, which creates fake IPs. There is nothing behind this fake IP, but I wanted just to create the DNS records using core DNS. And I will run the DNS resolution from multiple ways to show you that actually there was the bug in Go library. So first of all, we'll take core DNS IP, and then I will run some test pods with some basic Linux image where I have some dig, for example, command to run this DNS resolution. I created a pod, and then I will SSH to this pod and run the command to check if the DNS resolution is working. So first, I will test it using the dig. And you can see here I'm asking for DNS query for huge service. This is the headless service that I created. And I'm asking to this IP where my core DNS, which is running in this Kind cluster, is hosted. And I'm using a TCP protocol for this. And as you can see, there are multiple IPs that I receive in my response. But I wanted to test this with my Go resolver. So I created a Go binary, and I built it with Docker, using a Docker. So I can run this inside this cluster and test how Go resolution works. When I build my Docker image, then to use this image, I need to load this image into the kind. And kind supports this command by load docker image command, where I'm passing the image name and the tag. And one thing is that please do not use latest tag, because there is this, I'm calling this bug, but Antonio said it's a feature, that actually Kubernetes is polling the image, but actually the image is already loaded on the node, so there is the problem, and image cannot be found. To see if the image, we need to exec to the node and just list those images. And as you can see, I already loaded 2 DNS stats images. One is built with Go 1.22 version, another is 1.23 to test it. And one important thing is, as you can see here, the full path of this image is Docker IO library. And I think this is a very important information, because if you want to use this image and run this inside the pod, we need to pass the whole path, even though that with kind load, we just been passing the image name and the latest tag. So I created some manifest for pod, where I'm going to use this image, and I will send the query for the same core DNS endpoint, and I will build FQDN with my huge service I already created. So let's take a look at the logs and see what's going on. In the logs, we can see that there's a problem with service resolution. No such host we are receiving, and we can see the server and the FQDN name, which is actually odd, because we already seen with dig command that actually the records are present there. We can see it with NSLOOKUP. So this is proving that in Go 1.22 there is some problem, and I built the same image with Go 1.23 version, and I will run it also in the pod, and we can see, hopefully, that the resolution is working. Yes. Okay, so this was testing DNS, and another case study that we prefer was about kube-proxy. Kube-proxy, this is networking component which is responsible for programming the Kubernetes data path. It's creating the rules for resolution from service VIP to the pod. And again, here kube-proxy can be run in Kubernetes in multiple modes. One of them is using IP table modes. And it turns out that here again, when we have the service, this time not headless service, but cluster IP service, which has multiple endpoints, the programming latency is very, very high. It is related because the IP table has linear search, and also while programming the data path, the restore operation is copying all of those rules into the kernel, which is increasing data path programming. And again, I prepare some demo and cluster to solve this problem with IP table and compare it to NF table. And we will run the test with 2 clusters, one with running kube-proxy with IP table mode and another with NF table mode. And yes, here's the demo. For this demo, I prepared a config cluster using Kubernetes version 1.29. And this is also showing how easily we can modify cluster using the kind, because kind has this, let's say, lightweight configuration way. For this demo, I will enable monitoring with logging. I will increase the logging verbosity, and I will enable metrics. And before this talk, I also run some service which is exposing the metrics through Prometheus UI, so I can actually access those metrics from my web browser. So this is the Prometheus service. This is a node port service, and then this port is exposed on every node. But if someone is running the kind cluster remotely, like I usually do, to access the Prometheus UI from the web browser, we need to forward the port from this node and, for example, the worker node and this node port, this port for node port service to our remote machine. We can do this by binding to the port. I choose here port 9092, but you can choose a different one, but just make sure that it doesn't overlap with others. So later I will show how to access this metrics. I will run some tests to create this cluster IP service with multiple endpoints. So first, let's connect to some worker node and run top command. We will have a better view what's going on into the cluster while we are running the test. And I have some script prepare, which is creating the cluster IP service. Then it is creating the endpoint slice with 50,000 endpoints. And let's take a look, see what's going on in the cluster. We can see at the top command that IP table restore process is working and is eating a lot of CPU. But my endpoints, my IPs in these endpoint slices, they are fake endpoints. So I can actually test the networking if this is working. So I needed to create new service, this time the real one, some web application, so I can run some benchmarking and see if this is working. So this service web app, I'm creating some basic web application, and then I will run some test pod. And within this pod, I will run some benchmarking to check if how this is working. Okay, so we are running the command, and we can see that right now it is processing. So while it's processing, we can go to take a look at the metrics, and kube-proxy is exporting multiple metrics. One of them is, for example, IP table rules total. This is the number of IP table rules that we created for the service. We can see that we have more than 100K rules created, so that's a lot. But another metric which we are interested in is the programming latency, because this is the way that we know how fast we can actually use our application. And you can see here that there are some metrics exported, but after that there's this blank spot. That means that in this time, kube-proxy didn't, reported the latency because the latency was not, because the process haven't finished. We can see that our benchmarking timeouted. That means that the web application is not accessible. So let's take a look at the kube-proxy logs and see what's going on there. I increased the verbosity, so we should have better visibility what's going on there. And we can see that the last command is reloading service IP. And in top command, we can see that IP table restore is still going on. That means that this process is taking very long. So while the IP table is still working, we can actually switch to testing NF tables. And actually, this is really good that with kind, we can switch between clusters using kubectl context without impacting all of clusters each other. So IP tables are still processing, while we can run the same test, the same scenario for cluster with NF table. To enable NF table kube-proxy with NF table mode, we need to enable feature gates, and we need to provide some basic configuration. And for this cluster that I created, I will run the same test. I will create the same cluster IP service with the same number of endpoints, and we will see how fast we can access different web applications that we will create in this in the same cluster. I will also connect to one of the workers and run top command to see what is the CPU and memory utilization for my test. Now I'm creating this service and its endpoints, and we can see how differently the cluster behaves. Kube-proxy process is working and is evoking NFT process, and it's also working really hard, but it's not eating 100% of CPU. And we can see right now that the process finished. That means that the data planes should be programmed. So let's create the web application and run some benchmarking to see if this is working. Yeah, and we can see that that was fast. This time we have some real numbers, and that NF table is performance for high-scale services is working really way much better than IP tables.
Well, this is just to showing how you can use Kind for doing this. If you are interested in testing performance of kube-proxy with Kind, you have Nadia here, and you watch the presentation she made in last KubeCon, because it's awesome. He found 2 kernel bugs, I think, plus 1 feature, plus. So the key point here is that you can do scale testing or performance testing, with all the limitations in your laptop. You don't need to be connected to anything. You can switch between cluster and whatever. The important thing here is that you need to understand how to break down the problem. Am I able to isolate everything? Do I write the hub interfaces? What are the APIs that I need to modify? And then the nice thing is that you can also script it. You have this weird race condition or bug that you know more or less how it happens, so what can trigger, you have everything in your laptop, right? And with containers, so you can do Docker exec or whatever thing that you want to do, and it quickly, you are able to reproduce things much faster. So I don't think that anything more that we can add here is just a tool. You can use it, but it will never be a replacement of real testing, right? Doesn't mean that because you can run the E2E testing Kind, that is a necessary condition for a release. You need to run your things in production, because Kind is, the way that I define it, is kind of a perfect E2E scenario, because you have low latency. You have, just think, all the network are only buffered. They never go through the interfaces or all the things. So you have super high latency, low latency and high throughput. So the races that you can hit is because the system is really fast. But usually the problems are when the system is really slow, right? Or one part of the system is slow. That's why Kind is necessary condition, but it's not enough condition for a release. We still need to do scale testing and E2E. But I think that's it. If you have any questions, we are happy to answer now. Well, yeah, we can use Gateway for testing with Kind.
Unrelated, well, somewhat related, like not the main point, but it showed like a huge increase for NF tables. Did you quantify how much better it was?
Nadia, do you want to come and answer the question?
I don't have my slides with me, but yes, we did.
Okay.
There is a whole blog post on NF tables update, and there is a talk from the previous KubeCon with even more like graphs and comparisons.
Okay, cool.
So the key point on that is we knew beforehand where were the problem, right, that we wanted to address. When we knew that IP tables need to load the entire blob of rules, right? So what do we need? Just create 1,000 of rules. How do we create those 1,000 of rules? Create one endpoint. kube-proxy doesn't understand if that exists or not. So we create this fake endpoint like with, I don't know, would you say?
50K.
Yeah, but you started with 100K.
Yeah, I started 100K. It was like 20 minutes to program it. So I didn't have patience to do this for demo.
No, but that's the key, right? You get now the proof that what you are trying to test is real. You are not able to load these things. So we know that. And the other thing that we knew is that, we know that IP tables do linear search for matching. So we need to find a way to generate the rules so a packet will trigger all these linear things. Right? So that's what we build. Let's build that scenario, let's add the metrics and the logs, and then get the results. And yeah, it worked pretty well. Two kernel bugs, one feature. It was impressive. It was Nadia work, so I don't want to take credit of that. Cool. No more questions? Nobody with scalability problems with Kai? Let me, before you move it, there is another problem. When you hit scalability problems, then you hit scalability problems with the kernel. So you are going to run off I-notify limits on all these weird things that you don't even know that exist until you hit those problems. So the scalability problem moved to the kernel problem.
I guess this is more of a comment than a question, but using kind for debugging and troubleshooting can also happen maybe in GitHub Actions with tests and that sort of stuff. And I think, Antonio, you have a few examples of that. I could be wrong. I think I learned that from you, but at work for E2E tests, it's easy enough just to, in GitHub Actions, spin up a cluster, install your things, test them, and be done with it. So it's quite versatile, which I quite like.
So let's put something. When you do E2E, you do functionality testing, but then you want this functionality to work in all places, right? And when you go in Kind and GitHub and you optimize for everything, the test is really happy. The controller is not going to have races. The controller is going to depend on another component that updates another thing, that updates another thing. And the problem is when one of these things start to lag, right? And this in kind environments and this kind of thing that are super optimized is not going to fail. That's the happy case, right? The problem is when you have all these chains of things that need to generate something, and one of the things fails. And this usually happens you have, right now we have a blocking bug for the release with the load balances. That depends on an external API. They need to create a load balancer, that the load balancer, whatever. Then, I don't know how many fixes we have in that controller, but you only hit this problem when the system is too slow and too large. So you're never going to hit that in Kind. So what I'm saying is, and user doesn't have Kind clusters. They have real cluster. And then you have kernel bugs. You have weird network driver bugs. I always say network because it's the thing that they need to debug. But there are other things. And that's the main problem, right? Is you need to run this across all the real systems that people run to at least hit most of the problems that they are going to hit.
Thank you for the talk. Have you considered running kind of more application layer workloads as well? There's for example, the observability demo from OpenTelemetry has, APIs HTTP requests that you can load. You can run a load test on a system. Do you do that as well, or do you focus on kind of just the control plane? Or rather, could this be extended to a system that runs more application layer tests as well?
That's the point I was doing with the methodology, right? And I get a lot of feedback from these people. Oh, I ran this project. Okay, and you give me some numbers. I don't know what those numbers are. Great, are bad, are good. So that's why we had this talk in the last QCon to move to a more SLI-oriented performance, right? So what do you really try to improve? What is the thing that you want to go up or go down? Just first define that, then run your test. And then, for example, if I don't know, I see a lot of this testing networking performance. If you test in Kind, you are testing a buffer. If you want to test performance in your cluster, you are testing the NIC, the CPU of the server. So see the difference, right, is you may get great results, but they're going to be meaningless for the people that is going to run in production. So you can do that kind of testing, but my advice is understand the metric that you want to optimize, understand how the assumption that you are going to make, and then evaluate the results. But running things just for running is going to give you results, but it's going to be hard to attain an answer of those results. I don't know if that answers the question.
Right, but you could think about somebody wanting to stress test OpenTelemetry or stress test authentication built as a plugin on top.
Yeah, but that's the point. Is you do OpenTelemetry and you know exactly the problem. That's going to the example of kube-proxy. We knew exactly the two things that were slow that we wanted to solve, right? So I think my suggestion is the same. Is you need to know exactly the things that you want to optimize, emulate that environment, create the workload, and see what and develop against that workload. So the thing is that you have a regression test now, right? You have a platform that you can automate to test regression on that. But you need to identify those things and create this, environment that emulate the thing that you want to emulate. Otherwise, it's going to be environment specific, and you get things like, oh, I don't get the performance that you're telling me. Okay, thank you. Okay, well, if there are no more questions, thank you for coming and use kind.
Thank you.